Welcome you all for the structure analysis course. In this class, we going to discuss about analysis of continuous beam with sinking of support. Analysis of continuous beam with sinking of support. This is a continuous lecture series, week 2, lecture number 2, CDT5. The code for this lecture is week 2, lecture 2, and the CDT5. The analysis of continuous beam with sinking of support. One of the support if sinks, how the bending moment will, how the moments will going to vary. We will going to see in this particular lesson, lecture. Okay. The outcome for the lecture, after completion of this lecture, student will be able to calculate the fixed moments for the different loadings and settlements, and also student will be able to analyze the continuous beam with sinking of support by using slope deflection method of analysis. So these are the two lecture outcomes. We will see the one problem related to this sinking of support. If the continuous one of the supports of continuous beam settled by delta. Let's see that. Problem is analyze the continuous beam as shown in figure by slope deflection method if support B sinks by 10 mm. If support B sinks by 10 mm, is saying that consider EI is equal to 4000 kilonewton per meter square. EI is equal to 4000 kilonewton per meter square is given. And for AB span, we have two span continuous beam. Span AB and span BC. Span AB and span BC. Span AB subjected to uniform distributed load of 20 kilonewton per meter, and for span BC subjected to 80 kilonewton acting at the center. The span is 4 meter. BC span is 4 meter. AB span is 8 meters. For AB span, the EI is 2EI. For BC span, EI is equal to EI. There is flexural rigidity for AB span is 2I. Flexural rigidity for BC span is EI. Now, for any type of problem, what is a overhanging or fixed or one fixed, another end is hinged. For any type of problem in the slope deflection method of analysis or overhanging, whatever it may be, sinking of support, rotation of support, whatever it may be, the first step in the slope deflection method of analysis is finding the fixed moments. So we have two spans, AB span and BC span. For AB span subjected to uniform distributed load. AB span is subjected to uniform distributed load. As I told you to remember these two formulas, these are very, very important formulas. First step, you need to calculate the fixed moments. So let us say this is A and it is B. The fixed moment can be calculated from this formula, WL square by 8, WL square by 12, and this is plus WL square by 12. So this is producing anti-clockwise effect, so it is negative, and if you're producing clockwise effect, this is positive. Okay. Substitute W is equal to 20, L is equal to 8. Here you're going to get MFAV is equal to fixed moment due to loading. MFAV is equal to minus 106.67 kilonewton meter. MVA is equal to plus 106.67 kilonewton meter. So coming to BC span, BC span is subjected to point load at the center. The beam is subjected to point load at the center. This is a symmetric point load at the center. This concentrated load. It is also symmetrical about vertical axis. Then MFBC will be producing anti-clockwise effect, that is minus WL by 8, which is producing anti-clockwise, plus WL by 8. MFCB is equal to plus WL by 8, which is producing clockwise effect. Okay. So now substitute here, W is equal to 8, L is equal to 4 divided by 8. You're going to get MFBC will be equal to minus 40 kilonewton meter, and MFCB is equal to plus 40. The magnitude is same, but sign is different. But because one is anti-clockwise, another one is clockwise. Okay. Now we'll move to the next step. The slope deflection method of what is the next step? Next step, developing slope deflection equations. So developing the slope deflection equation, formation of slope deflection equations. So we know the slope deflection equation for the beam. MAB will be equal to MFAB 2 EI by L into 2 theta A plus theta B minus 3 delta by Okay, this we can write this displacements. Theta A is unknown, theta A is 0, theta B is unknown, theta C is also unknown, theta C is also unknown. Okay, delta for all supports is 0. Delta is sorry not 0. Delta is not 0 here. Is saying that one of the support sinks by delta, that is 10 mm. So delta B is unknown kadandi. This is known value, that is 10 mm. 10 mm. Okay, you need to convert into meters, 10 to the power of minus 3 meters. Okay, so 10 mm support B is settled by, this is the difference from the previous problem. Delta B is 10 mm. Delta B is 10 mm. Delta C, delta A 0, delta C is also 0. Only delta B is equal to 10 mm. You need to remember this. Okay, now I'm writing MAB. I'm writing MAB. The equation is MAB plus 2A by L, 2 theta A plus theta B minus T delta Y. Once again I'll write here. MAB will be equal to MFAB plus 2 EI by L into 2 theta A plus theta B minus 3 delta by. Okay. So substitute MFAB is equal to 106.67 minus 12 because it is producing anti-clockwise effect, and EI is equal to 2 EI. Okay, so you calculate it. 2 theta A is unknown, theta A is 0, sorry, theta A is 0, theta B is unknown. Okay, delta value here. So delta value, so which downward settlement sinks by delta. So delta is downward settlement, so we need to consider that value. Delta B will be equal to minus 10 mm, minus 10 mm, that is 0.01 meters, 0.01 meters. Okay, substitute delta is equal to 0.01 meter downward direction, that is minus 0.01 meter. Theta A is equal to 0. Substitute EI. In place of delta, we are substituting 0.010 with respect, sorry, with respect to the support, with respect to AB, with respect to AB, which is settling down, which is settling down. Okay, which is settling down, which is producing clockwise effect. So which is producing clockwise effect. So this will be considered to be positive. So theta A, the delta for AB span, we need to consider positive. Why? Because observe with respect to support A, support B is settling down. Support B is settling down. So which is producing, this is clockwise. So this is it, theta delta will be considered to be, delta will be considered to be positive. Delta will be considered to be positive. Okay. So substitute delta is equal to 0.01 meters. 0.01 meters. Okay, delta is equal to 0.01 meters. If you substitute it, you are going to develop MAB is equal, substitute all the values, you will going to get MAB is equal to 0.5 EI theta B minus this value is going to be consider, this is equation number 1. Equation number 1. Okay, consider similarly consider MBA. MBA support MBA. MBA. So MBA is going to MFBA. All right here. MBA will be equal to MFBA plus 2 EI by L. MFBA 2 EI by L into 2 theta B plus theta A minus 3 delta by L. So here this is also same. So theta B will be considered to be positive because with respect to A, B is settling down. With respect to A, B is settling down. That means which is clockwise in nature. So right, with respect to A, it is clockwise. Okay. So delta will be positive. Substitute delta is equal to 0.01 meters and theta A 0. Okay, theta B value untadandi. EI place lo 2 EI substitute cheyandi. L is equal to 8. BA is equal to plus 106.67. Substitute it. Finally, you are going to get MBA will be equal to EI theta B plus 99.17. This is equation 1. So now coming to the second span. You see the second span, this is BC span, this is B and this is C. With respect to C, B is settling down. B is settling down, which is producing anti-clockwise. So delta B, here we are consider minus delta. Delta will be considered minus delta B. So that is the thing you need to understand here. So with respect to C, with respect to right support, left support is settling down. With respect to right support, left support is settling down. Because of this, anti-clockwise effect will be there, so that will be considered to be negative. Delta value will be considered to be minus 0.01 meters. In case of BC span, we'll consider minus 0.01 meters. Okay. So I'll write equation, slope deflection equation. MBC will be equal to MFBC plus 2EI by L into 2 theta B plus theta C minus 3 delta by L. So delta value is equal to minus 0.01 meters. Theta C is unknown, theta B is unknown. EI, in place of EI, you substitute EI. L value, that is 4. L value 4. And MFBC will be equal to minus 30. Substitute it, you're going to get, finally you're going to get MBC will be equal to this one. This is you consider equation number 3. Similarly, you calculate MCB. So MCB, we know MCB, slope deflection equation for MCB is equal to MFCB plus 2EI by L into 2 theta C plus theta B minus 3 delta. The same thing. Delta will be equal to minus 0.01 meters. So, but because with respect to right support, left support is settling down. So, which is producing negative effect. That's why it is negative. Anti-clockwise, that means negative. Okay. Delta is equal to minus 0.01 meters. Theta B is unknown. Theta B is unknown. Theta C is also unknown. Because if you see the figure, given problem, theta B is a roller support and theta B is a roller support, C is also roller support. So theta B is unknown, theta C is also. Okay. Right. If you substitute delta value and theta values and EI values, theta value, EI value, finally you will going to get MCB will be equal to, so this is equation number 4. From these 4 equations, after developing this slope deflection equation, we need to move to this step 3. That is joint equilibrium equations. Joint equilibrium equation. Joint equation for the joint B. Joint equilibrium equation for joint B. Let us say this is B and this is A and this is C. MBA plus MBC will be equal to 0. That is joint equilibrium equation. From this joint equilibrium equation, if you substitute MBA and MBC here and equal to 0, you are going to get another equation. This is, let us say, this is equation number 5. Okay. And similarly, a joint C equal to 0, that is MCB is equal to 0. Joint summation of moments at joint C equal to 0. And C summation of moments at C equal to 0 joint equilibrium. This is a joint equilibrium equation. And that is not fixed one. That is not fixed one. Fixed is the joint moment is 0. This is roller gabati. I'll write joint equilibrium equations here, students. Observe carefully. Observe carefully. I want to erase this. The joint equilibrium equation, it is joint B will be there, joint C will be there. First problem, CDT3 lo, మనం ఏదో డిస్కస్ చేసాము అక్కడ ఫిక్స్డ్ సపోర్ట్ అండి ఫిక్స్డ్ సపోర్ట్ కాబట్టి సమ్మేషన్ ఆఫ్ మూమెంట్ ఎట్ C equal to 0 కాలేదు not 0 but here this is a roller support so for the joint equilibrium equation summation of moments at joint C will be equal to 0 that is the condition joint C దగ్గర ఏ మూమెంట్ ఉంది మరి MCB is only one moment is there so MCB ని మనము equal to 0 చేయాలి this is also one of the condition MCB equal to 0 ఇది ఒక కండిషన్ నెక్స్ట్ ఏంటి సమ్మేషన్ ఆఫ్ మూమెంట్స్ ఎట్ B equal to 0 ఇది ఇంకో కండిషన్ ఇది అది టూ జాయింట్ ఈక్విలిబ్రియం ఈక్వేషన్ సమ్మేషన్ ఆఫ్ మూమెంట్స్ ఎట్ B equal to 0 సమ్మేషన్ ఆఫ్ మూమెంట్స్ ఎట్ C equal to 0 these are the two joint equilibrium equation from summation of moments equal to B equal to 0 చేస్తే మీకు MBA plus MBC will be equal to 0 this is one and this is MCB equal to 0 this is another equation from this equations to substitute MBA plus MBC equal to 0 and MCB equal to 0, you're going to get EI theta B and EI theta C values. EI theta B value and EI theta C value, you're going to get EI theta B is equal to minus 35.24, EI theta C is equal to minus 27.3. So these values you need to substitute in equation 1, 2, 3, 4 in step 2. Okay. EI theta B and EI theta C substitute, you're going to get the final end moments. So these are the final moments. So these are the final moments. After this final moments, you need to draw the shear force diagrams and bending moment diagrams. So this is the variation of shear force diagram. This is bending moment diagram. So for the drawing of shear force and bending moment diagram, you will just refer CDT3 continuation topic, CDT3 continuation topic that I have posted in your WhatsApp. Thank you.